For this problem, we're going to write an equation for horizontal displacement. In this situation, we have Logan's playing on her swing. One full swing, that's front to back to front again, takes 6 seconds. And at the peak of her swing, she is at an angle of 42 degrees with the vertical. If her swing is 5 feet long, and we ignore all resistive forces, write an equation that relates her horizontal displacement from the rest position after time t. Since we're considering the initial time t0, that's in the rest position. The rest position is the vertical position, that is d is equal to 0. Then our equation is going to have the form d is equal to a times the sine of omega t. That's going to be the form of our equation. We're going to go ahead and look at a diagram. Consider this is our rest position for the swing, and here's at her highest point. That makes an angle of 42 degrees with the vertical, and the swing is 5 feet long. And this represents our value for A. The period is 6 seconds, so we'll have 6 is equal to 2 pi over omega. It means omega is equal to 2 pi divided by 6, which is equal to pi over 3 radians per second. From this diagram, we'll see that A divided by 5 is equal to the sine of 42 degrees. If we solve that for A, we'll find that A is equal to 5 times the sine of 42 degrees. Therefore, we go back to our model. Remember we said our equation would be D is equal to A times the sine of omega t. We're going to have 5 times the sine of 42 degrees times the sine of pi t over 3. Pi over 3 was omega. If we approximate the sine of 42 degrees, that gives us our equation that d is roughly 3.346 times the sine of pi over 3 times t, where t is in seconds.